Hello, this is Alex Young of NASA's Goddard Space Flight Center in the Sun today. Well, Sunspot Group Active Region 11429 is at it again. It started off on its journey across the Sun by giving us a couple of M-class flares, and then we saw an X flare. Well, now it's given us the second largest flare of the solar cycle, an X5. And then after that, we actually got another X1, and it's produced several CMEs. If we look at this from the GOES X-ray satellite in space, you can see almost the beginning of the day of March 7th in Universal Time, the big spike, and then the little bump right after that. If we zoom in, you see that there's the X5.4 and the X1. And we also saw this event from the X-ray pinhole camera on the SDO Eve spacecraft, SAM. See the bright flash there. These X-rays and extreme ultraviolet hit the Earth's atmosphere and ionize it. The ionosphere is affected on the side facing the Sun. You see these red patches. This is where radio blackouts occur. So we look here, you see the huge flash. That's the solar flare, the bright flash of X-rays. And then afterwards, you see material moving. That's actually where the CME is coming from. In this case, we see a bright flash, material moving away. There's a blast wave that comes out. We'll show you in a second. We look here at another viewpoint with some different wavelength. Again, you see all this material shooting out. You see jets moving out. Right after the M1 flare, the second one, look at this big wave of material come away. It gets kind of dark there. All of this stuff is moving around. That's where the CME is coming. Well, if you look higher up in the atmosphere with a higher temperature, you see the whole Sun wiggles. This is a blast wave, a coronal wave or EIT wave, often called a solar tsunami, moving across the Sun at around 1,000,000 miles an hour. And if we look at even higher up, a slightly higher temperature, we again see the flash from the flare, the wave, and then there's another one and another wave. And right down below, there's a big black patch. That's where material is coming away. As material leaves, there's less stuff to glow. So that's actually where material from the CME has come from. If we look at it with a running difference movie, where we take differences in the images, you can really see the two waves, the big one and the smaller one. And this created two coronal mass ejections, billions of tons of material. This is a view from the side with the stereo spacecraft. And when these CMEs come away, they scoop up material and they accelerate it, like creating these blasts of high-energy protons. When these protons hit the cameras in space, you see all of this snow, all of this speckle. Now, this is not the strongest one we've ever seen, because if it was, this image would be completely washed out, completely white. But what else is happening is that we've actually now seen the effects of one of the earlier coronal mass ejections from a few days ago. And this one is causing disturbances in the Earth's magnetosphere. This is creating currents in the upper atmosphere, created a geomagnetic storm. And this geomagnetic storm is going to create aurora. And then when the CMEs that occurred earlier this morning hit, later in a couple of days, we'll see the same thing again. They'll probably be stronger. But these CMEs have been off somewhat to the side, not exactly directly facing the Earth. So we're not sure yet if what the full impact is going to be. We're waiting to see the predictions from the NASA Goddard Space Weather Lab and NOAA's Space Weather Prediction Center to find out what exactly is going to happen. So again, what you're seeing here is this spectacular eruption. So several different parts, all part of one grand thing we call a solar eruptive event. You see the flash of light, that's the flare. Then you see this wave moving away and all this material, and that's what creates the CME. And the CME is scooping up particles, creating the proton storm. So thanks to everyone at all the different space agencies and instrument groups and researchers that have made all this possible. Come join us at Facebook, Twitter, and YouTube under The Sun Today. Thanks.